unmute the mic, that might help. So what we're gonna do is just some basic work on the app, and what we encounter today is what we encounter. So this is what I would normally just be doing. I just figured I'd stream it. It's one of the first jobs I've ever had where I can actually work publicly. There's not a whole lot of trade secrets here in this code, so it'd be fun to just kind of interact with people. All right. So what we're doing today is we have our download manager. Is that what it's called? The download. We have the analysis. Let's see here. Look at it this way. So in our data model, we have our system that does the downloads, and I'm forgetting what we call this because I haven't dealt with it in a while. But I'll tell you what we can do, entity category. So we currently store everything in SQLite in this really wonky method where basically it's a key value store. Everything is stored like just by keys, and we look it all up and it's stored in JSON in the values. And we're gonna switch that over to a new database system. And what we're gonna do for that is the download states. Okay, so this is what we need to look at switching over. So this is the state of an active download, and as this updates, we write out the state so we can restart it, as well as this task status. Idle, pause, downloading, downloaded, completed. This is going to be fun to switch over. Type specific data. So we have HTTP state and then XML state. Interestingly, there's not a whole lot of data in here. It's mostly just the query for both. That's interesting. Downloaded bytes. And I just now realized my chat window isn't very visible. There we go. So the next question would be, how often do we save this? Because our new database stores history, and we don't really want to spam the transaction log with a ton of data. So what I would want to figure out is, how often do we save this? Create, download, here's our download service. Get from state. All right, and then here, so this is like showing all download states. Okay, so this isn't terrible. We want to find out where we save the actual states, and then that'll tell us how often we save it, and if that's going to blow out the transaction store. So update in data store. Nope. We want find usages of this. So when we complete, we do it. We delete it when it's canceled. Persist on start. So it's going to be involving this. Find usages of that. So we put here and persist on start. So it's interesting. It looks like we don't ever actually update, which is good. I mean, that's fine. We update it in one place. When we complete, when it's canceled, we delete it. Oh, looks like we also do on pause. Update persist. Why did it not show that? So if we go to this, oh, update persistent state. There we go. Okay. A little bit of a spaghetti here. Edit, download. Okay. All right. So when we call suspend, we save it. All right. That makes sense, I guess. So it's on suspend, on start of download, on paused. Cool, that works. So normally we would have two updates. We would insert the data when we start the download, and when it completes we update, and then if there's a pause, we have one or two extra updates. That's completely fine. I just want to make sure we weren't like chunking the download and updating the state on every download, because in that case, you know, if you downloaded a 10 gig file, you may have, you know, 1,000 updates, and it's just, that's pointless. We would want to dedupe that. So with that, let's get started then. So this whole, what we are ripping out today, to start with, is this part here. We're going from this iData store to a connection, and this is a database called Mnemonic that I've been working on for a while. It borrows heavily from Datomic and a bunch of other databases that kind of sprung up from that. So what we're going to do first is yank out the store. There we go. This is my favorite band, by the way. We're listening to The Midnight. The Midnight is a synthwave band. Okay, so next thing we need to do is to create the actual, let's see here, the actual state object that we will be persisting. So down here, when we save this, what are we saving off? Okay, we are saving, this is all through export state. So we have this downloader state that exports, and it's this entity here. So fun enough, we the static class, we switch this to a static class. This is no longer an entity, and we need to implement these attributes. So the download task status is an enum, right? Yep. So we'll see how we end up being able to implement this. Enums get a little wonky, but we'll add a new attribute here. Enum attribute. So in this database system, we have entities that have attributes and values, and we define the attributes, and the attributes have a type safe value. So what we're doing here is defining an attribute that is from a enum. Oh, sure enough, there is an enum. I don't remember that being there. Okay, so this is going to be a attribute from mnemonic.db of t, backed by a int. If it's not backed by an int, we would have to create another instance of these, which is fine. And then string namespace, string name. This is what we use to identify the attribute. And then down here, we back this by a value tag of uint 32, and then namespace, and then name. And then we got to implement how we convert it from the low level types to the high level. Not hash code, goodness, that's wrong. Int of value. See, I don't like that. Can we do where it's a enum and an int? Does that work? Nope. So there is something enum extensions. Let's look that up here. There's an enum extensions source generator. Enum generators, is that it? Is defined, parse, get values, string values. No, it doesn't give us what we want there. Has flag.
All my good intentions, there's a shadow in the dark. He comes to me infrequently and breaks your perfect heart.
Not really sure how we want to implement this. We could do it as a string. I guess that's not a terrible approach. Or just as a, we just do it as a byte. In this case, it's not, there aren't that many of them. Byte attribute. And we'll rename this. So we'll do it as a uint8 attribute for storing a uint8. So too low level. Does not need to be an int, it's a byte. Try that again. There we go. And this is going to be a byte to a byte again. And this is byte. Cool. So now that we have that byte attribute, we will be able to start implementing that in our redefinition of the download state. So instead of status, we'll store this as a byte, and then we will convert it on the fly. Yeah, we kind of have to do it that way, don't we? Unless we want to create an attribute for every single... where's this file that we're working in? This is networking downloaders. We could create an attribute in here for that. All right, we're splitting hairs at this point. Okay, cool. So public static read only view in what was byte attribute we called it. Clean that up. Status. So we're going to create a static private const string namespace equals that. Downloader's task state. Yeah, we'll do downloader state. And then we do namespace and then name of status. So the status, so the next thing we need to think about is if we want to index or not. I actually don't think we do. Will we ever index this purely, will we ever look up purely the active downloads? Yeah. Yeah, we would. Yeah. So is indexed equals true. Okay. So now we have the download path. Public static string, static read only string attribute. And this is download path. I don't know that we need this indexed because we're never going to actually say what is the status of this thing on disk. We wouldn't do that. So we don't need this indexed. Friendly name. Same thing for that. Public static read only long attribute downloaded bytes. So the name of the game is game domain I thought we had one of these. Did we store that as a string though? That was in download. That was disk state. The state registry. This used something that I thought had a domain in it. Let's see. Gain domain attribute. We do, but this is in. Where is this at? Data model attributes. And we are at a higher level than that. And the game domain is where? Games, DTOs. Abstractions, games, DTOs. This is really in game locators. Yeah. That would reference the entire data model, which is not what we want. Okay. So we will need to move that. So if we find this class, which is in our data model, down here, attributes, game domain attribute, and then we'll move this up into the locators. Do we want it here, or do we want it at the, probably in the attributes level, right? So mnemonic to be attributes. Yeah, we'll want it in here, and then we can change the name of this, and then we can pull in game domain into here to resolve that. There we go, that stopped complaining. Cool. And then we have our downloader state here. And then, cool. So that one's resolved. Then public required, we have the game name of the game. The mod will be a name of the game. Well, what's the difference? I don't think we need game name and game domain. Size and bytes, public static read only, size attribute. Actually, we can make this a size attribute as well. Cool. Version. So public static read only string attribute version. Okay, so do we need game domain indexed? Yeah, probably. Is indexed true. Cool. So when we create this state, what do we use with export state? We save it, we delete it. Okay, cool. So one of the things that we have to adapt here is that we're moving from this model of like single puts to a more transactional system. So what I was looking at there is, can this thing that exports this state export it directly into a transaction? And the answer is in fact yes. So export state here will need to take a transaction now. I download task. Let's see here, I transaction tx, and then do we want to give it an entity ID? Probably. And then, so we have this downloader state, and we got rid of the downloader state, the actual class, and we're going to replace that with a model. So we have all these attributes, and we're grouping them together into a model that we can use to then read and write the model, the data. Okay, so class model, right, transaction tx entity. And this is a different entity than the one up here. Yeah, we don't want to inherit from entity. We want the other entity, which is this one. TX. Cool. So now is when we map that one value to a downloader state. Not downloader state. What is it? Status. Download status. Now that's going to return a byte, so we need to do downloader, download task status. There you go. And then set. Cool. Public, what's in it? Download path. Downloaded bytes. Okay, cool. And then public game domain. Okay, so we have game domain size version, all that. Cool. Then we have type specific data. Now this is going to be handled differently in this system because we're going to attach this right onto the downloader state itself. So if we find usages here, we have game name, game domain size and bytes and version. Do we actually type specific data here? Find usages. Where's our type specific? So this gets a URL and this gets a URL. Okay. So we are going to not do anything with that quite yet. So at start, we are just going to give it a new tx.temp ID. There we go. So we have the model, and then we just need to tx.commit like that, and then persist on start is going to return task. So now we're going to have to populate up the async calls through the rest of this system, which I don't think it's going to be that bad. So async start, or start async, that starts the actual task. Okay, good. So this becomes a task that returns a task. Okay, it's a little weird. We'll have to look at where this is called. Okay. So now when we do a delete, who calls delete? Because we don't ever actually want to delete. We have on canceled. Canceled is the only place where we do a delete. Okay. Can we set the status to cancel them? That should probably work, right? So we're going to do using var tx equals column.begin transaction, and then the we're going to find the initial state. This needs to include the actual task ID, right? That's the status. Okay, so this actual task needs a unique ID. Yeah. Task ID. So what we can do here when we set the status is we actually can just do tx.add, and we do task ID status to status, and then we commit. And that's about how easy it is. Okay, so now we can set the status, and then we have update in store. But what are we actually updating here? We would be updating the status. We would be updating the downloaded amount, right? That's about all we would do. So using var tx equals con.begin transaction, and then we would say add the status, add downloaded bytes, await, commit. Size in bytes, this is a ulong. You know, why is this not a size? There we go. Boom. So now we delete that. So we have update and data sort, set status. Actually, we can merge these two, right? So we can do this, and then we just do update in data store. So now we go to this code here that broke. Get total progress. Downloaded size bytes. Size, total size. Why can that not be? So the reason we use these sort of we're called nominal typing, where we're actually taking these things like size and redefining them, wrapping them in another container. So if you see here, size is actually just a ulong inside of a it's a ulong wrapped in a struct. And the reason we do this is that we can like implement all of these. So for instance, dividing a size by a time span results in bandwidth, which is kind of cool. And if you think about it that way, like 1 gigabyte divided by 3 seconds is, okay, 1 gigabyte divided by 4 seconds is, 250 megabytes per second, which is bandwidth as opposed to a size. So it allows us to develop this language. Now, the problem we have here is size bytes is ulong size. Cool. And we can always convert back to the value to get this sort of thing. Although I thought size had a complete, or had a percentage thing. I think, didn't we have that with a percentage? I thought I implemented that. The ability to create clamped. I thought there was a thing to do get a percentage from this. No. Unless it's on size. But did size have a percent? No. Okay, I never did implement that. Oh well. Find usages of this. Okay, so we're going to propagate the task through the rest of this code. Now this breaks some things because this now no longer implements the upload, let's see, update state, update persistent state. So we'll have to propagate that through the rest of the code. So suspend. What I'm doing for a lot of this is looking where we suspend and seeing if we should propagate this even further up the chain. Almost think we should. Because all of this is going to end up needing them. Okay. All right, we're just going to rework this. So, update on data store takes a task and a status. We don't need the status. Cool. Okay, so now in this download service, let's go here and look at all of these operations that add task on complete should be a task, on canceled task, on paused task, on resumed task, get throughput, and these will not require a asynchronous code, so we're good with that. All right, so we need to start rewriting the rest of this service. Yeah, kind of scattered at this point. I'm gonna have to come back to that. That's weird. We don't delete stuff anymore. What we're going to do instead is update in data store task dot status canceled. We're going to add another one for completed so now we have canceled. Why does that much? Canceled has 2 L's. Well, I guess it's right there. Cool. So, all right. So we add the task.
We have one more song for you tonight.
I'm gonna send the link to this to a few other places.
Just go.
We got a few viewers. Hello, everyone. All right, cool. So what we're looking at now is some of this impedance mismatch here. So let's look at this function here. Get all items to resume. So in the past, we're saying all the items that are not completed we now want all items that are not completed and not canceled. And then we load those up and cast them to an iDownload task. So this becomes we get the database, and then we say tasks are db.findIndexed by, this is backwards, and then select. So this is where this downloading status is downloading. This is not what we want though. We really kind of want all statuses. Okay, well, let's look at this. Kind of want all statuses, and then we filter out the ones that are not of the type we want. Now, the problem with this approach is it's going to be a linear scan. So this will slow down over time. The more downloads you have, this call will become slower. Probably not a huge issue. What's our other option? Download status. Where's that enum? Download, whatever is it called? There we go. So we have these index, which means that we can do an index of different ones and join them together. But we're going to want everything that's downloading, installed, paused, idle. We just don't want these two. Yeah, you know what? We're just going to do everything for now, and then if it gets too slow, we'll do something better out of it. Cool. So we get the status, and then .where does not equal completed, and not equal canceled. So I think that's it. Well, that says entity ID equals that, which is not correct. We're going to have to cast this into a, get the object first, the entity first, and then we can say x.status is not equal completed, and it is not equal canceled, and then we just return that. So that's what I do like about this new system. Then we do have this get tasks from state. So we do that, and then we do select get task from state. And and that's it. So why does this sometimes return null? Unrecognized. So it could be HTTP download state or NXM download state. Okay. So we have this kind of weird polymorphism going on here. Not sure I like that. But we'll rework that in a bit. Not as clean as I would have hoped, but it works. Cool. And with that, we look at this type specific data. So we have this restore from suspended. All right. Yeah, so the question was, we currently only record the in-progress downloads for persisting between app sessions. We don't need history here. That's correct. In which case, we can set all these attributes to no history. I also did look at it earlier, and the amount of churn on these attributes is pretty low. So on a normal usage, you would have one to create the download, and then one when it's completed. So 2 transactions per download. And then the other case is when you pause, you get like 2 transactions. So it's pretty low. It's at least not like every single chunk we're not getting a new transaction. The other thing that I'm running into here. So let's talk about this a little bit, because this is a problem I need to solve. So in this model, which follows the datomic model, if you want to look up databases like this, it's XTDB, datomic, data hike, and there's one other one I ran into the other day that I don't know what the AI is doing here. So what these do is you store all your data as entity, attribute, EA, AV, right? And the problem with this approach here is there's nothing that is a type discriminator. So doing this sort of thing, like saying, getting the type specific data type, so either HTTP download state or NXM download state, is a little hard. The way this is done in Clojure, where this comes from, is you do what's called predicate dispatch. And you would have something that says like, what is a Nexus download state? It's any entity that has the attributes that I define as being the discriminators for the Nexus download state. This is called multi-methods in Clojure. But it's kind of a cool way of having, like, you can have multiple overlapping methods of dispatch based upon looking at attributes. It's kind of what I want here, but the problem is casting that into a class is really hard. So if we look at NXM download state, what we really only have is this query string. So our discriminator would be something like, bool is is this, right? And it would be something like, it would be this if e dot contains nxm download state dot query. But then we still have to cast it to this somehow. So it becomes this weird thing of like, we got to check, and then we have to also construct this. Because what we want this to inherit from is not entity. Well, we could from entity, but also we'd like to have it from the downloader state. I think it's the, yeah. So like, we kind of want this. But we don't have a good way of what becomes a problem is telling the rest of the system about this, because what we want is we want this system here. Sorry, I'm using you all as a rubber duck here, kind of just throwing stuff at the wall, and then hopefully we figure something out here. So what we want is this value, or actually it's now state, because I've folded all these attributes into here, but we'd have the same problem anyway. We really want like this, is to say like we want to look at the C# type here in dispatch, but that doesn't help us. Now C# does have this, which is a pattern matching thing. I don't know how we hook into that. So if we said, like, you could say Nexus Mods download state. Now this is wrong, but what this would say is like, if state has this property on it, and you could do, like, you do like 42 to say like, if it has a property on it and it equals that, then do this. That works. But we don't want a property. We want something else. We want a, so our entities, if we have an entity, we can look up Nexus Mods attribute, or XM, XM, state dot query. You can do this. So, because we treat entities as collections of attributes. So let's look that up here in a browser. Let's see. C# pattern matching collections. So we'll look at this here. So we can do something as a number, type tests, which is what we're doing before. We can do discrete values, relational patterns. This is what we're looking for, multiple inputs. So if we have a record with items and costs as properties, we can match. I didn't know we could even do predicates on that there. That's pretty sweet. Doesn't help us here. List patterns. So we can do this. That's actually really cool for some other stuff I want to do, but not here. Okay. Oh, the first two arms examine two properties of the order clause. The third examines only the cost. The next checks against null. If the order type defines a suitable deconstruct method, you can omit the property names. Hmm.
I'm sorry, we're like years away. I bite your lip, and you taste like summertime. I can't forget.
So this is with records. Trying to think how we might. Thinking if there's a way we can abuse the syntax to get what we want, but I'm not seeing it here. And this also exposes another problem, and this is something that Clojure kind of fights against in its implementation, is that this is what's known as closed dispatch, whereas the things that you can dispatch on here are limited by this. If you want to add a new thing, a new dispatch, you got to add it here. Normal polymorphism in C# with interfaces is open dispatch, in the sense that you can like have another class in a completely different library implement that interface, and then it just works with everything. So this is suboptimal, and we have this problem already in the code here, right? Because like you can have HTTP or Nexus, but if you ever want to add another thing in here, you have to go and modify this code. Not optimal. Yes, we have a list of attributes that an entity has. Entities are themselves, we can jump into that. An entity, well, that's the wrong entity. That's always fun. We have two definitions of entities in the middle of converting this code over, so that's all sorts of fun. Download. There we go. So on this model, an entity is a... No, that's not what I'm looking for. An entity is a... It's not showing it here, but it's a read-only collection of attributes. So we have contains out of an attribute, and we have get. We can get the value of an attribute and an enumerator of all the datums in it. So that would be the entity attribute value, and we can pull out of that. So a datum itself has the attribute ID, and you can resolve it down to the attribute itself. So yeah, it's possible to treat them like a list, or a set technically, but this is old code. I don't know if I forked the wrong. I mean, this is what it's pulled here is not not up to date. Okay. So back to the issue at hand here. So this is the problem we ran into way back when we first started working on some of this. We have this thing in this system called a type finder. And this is what gets around a really crappy problem we have, which is we want to know all of the implementers of a given type in the entire application, but we want to allow people to add stuff into it later, and like we can do that some with dependency injection. I don't forget why we didn't use dependency injection here. I think it might be because they don't have a common ancestor.
You have the thought, are these guys having fun? Yes.
Yeah, I think that might be it. I really like this music, but the problem is the talking's annoying me after a while. I'm gonna have to, for tomorrow or next time I do this, I'm gonna get some purely instrumental synthwave music, and eventually we'll get chat in the middle. but I'm a noob at streaming and I haven't figured all this stuff out yet.
When the song happens to be about trauma, this might not be your song, but if this is your song, you can sing it as loud as you want, okay?
Okay. So let's think about this as far as the dispatch goes.
Unstable, daddy gone under the table, but you found a song in your heart, and you learn how to fight, how to starve, how to survive. When the others blocked your light, you learn to see beyond the stars. In this curse of small desires, too easily acquired. Now it's time to set your gasoline heart on fire. Kill your demons, kill them dead, and you're immune in your bed, in your heart. Don't you look good in
Yeah. So, I mean, what we can do for now, because I don't know that I have enough information to solve this right at this point. So instead of solving it, we're going to keep the status quo, I think. And if we go to our download service and we do this dispatch, what we can do is just something like this, which is if state dot contains nxm we can just do this, load from nxm, else if right. So we can like just do a linear, like a bunch of ifs, and that sucks because it's not open, it's not pretty, but it's no worse than what we have. You know. So we have this HTTP download state. So let's move this up here, and what that would look like is this. And then we need to actually figure out what this HTTP download task has. So what's our specific task data? So the HTTP download state is this. And we're just going to rewrite this public static class. And we're just going to define these attributes on here. So the URL is a public static read only. Wow, there is some serious lag on this, isn't there? Haha. I just realized that the stream is like 5 minutes behind where I'm at. So I'm living in the future, guys. I'll look at doing low latency streaming on the next one. I didn't realize it was that bad. All right, public static read only URL. Define our namespace. Private const string namespace. I don't think we'll ever need to query that, so we're not going to. Why is this URL attribute? Oh, this is the wrong URL attribute. I know I have a URL attribute. Is that also down in the wrong? Oh, you know what? That's in the test namespace for mnemonic. That's actually not in here. Okay. Add class URL attribute. value tag. The value tag here is how we store it, and then cool. And then we're gonna adapt this. Cool. Why? Oh, yeah, this is messed up. All right. And then technically this is a URI, not a URL, so we will rename this to URI. I actually don't know the difference. I've never cared to know the difference, but whatever. Okay, so we have a URI attribute, so now we go back here to download state and do URI attribute. We're just going to name this URI. Okay, cool. So now we do have a discriminator that we can use to pull out the information for this, which is good. And then if we go to our download task, we have export state and downloader state create. So we do have this downloader state. We need to invert the concern here. Yeah. We're going to invert how we do this a bit, because a lot of this data is yeah, so in the past what we're kind of doing is pulling types, like get me a serializable type that I can then shove further down, that I can combine into another class and then finally save that to JSON. We're kind of inverting that around, where we have a transaction and we have an entity ID, and anyone they want can just dump their namespaced attributes onto this thing. And so we're kind of flipping it around, where before we would pull from the more specific classes, what's your data, and instead now we're sending, like here's what we're going to serialize, and everybody can take that, add stuff to it. So where is this called? It's called here, and this is called from export state, which is called here and here. Oh, it's only ever called here. Okay. This isn't great. I'm just seeing how much of this code I want to actually like. Want to clean up or not. Okay. Let's look at the HTTP download task first of all. What's a little weird here is that the children are calling into the parent, right? So we have owner here, and we're like resume, and then we're calling finalize download async, start or resume download. Update persisted state. So export state, we definitely want that to take a transaction. Let's look at the download task here to see what we actually have. Oh, I want to do that as well, but we'll do that in a second. So this download task has owner, status, friendly name, and then this export state. Now this is used here, and only here. Okay. So I think we can really just adapt this entire thing to use an entity. Okay, so let's look at our implementation of this. And it's the export, it's called export state. Yeah, so it's complaining here that that's not matching, and we do I transaction tx and the entity ID. Now the question is, do we need any of this? I don't think we do. If we go here to this downloader state, this is like this is mapping these things to this. So it's mapping these traits to values. But what's interesting is that we don't necessarily need these traits anymore. So if we go to this, who uses this? We use it here. We implement it there. The view model says I have game name, and then it returns the game name. We can also update that to use the entity. I think we can simplify all that fairly dramatically. What I'm kind of trying to avoid here is a certain level of like this copying back and forth, right? We don't necessarily need that. We can just save this state into our like, where are we saving this like game name to, right? We're setting, we have all this here. Instead, what we can do is have we just have private downloader. I'm having a bit of time remembering downloader state. Set it to null for now. But if in here we just do state equals state. Oh, we want so we have downloader state, and we set the downloader state to state. Then we don't need these default downloaded size. Probably need the default downloaded size equal downloaded bytes dot value. And we convert that to a long. We are in the NXM one. I do want to redo the HTTP one first. HTTP download task, because this one's going to be a lot simpler to adapt. So essentially what we're going to do is start using the model more directly here. And like so for here, state.contains HTTP So if it doesn't contain the URI, our specific URI, then we know it's not us. So we're kind of doing a poor man's predicate dispatch here. We don't need that. We don't need that. Who uses this? We only ever use it here. So if we do this, we change this to size. So that. These changes are gonna just go throughout the entire application, but it's gonna be cleaner when we're done. So, here we go. Okay, we'll fix that later because I don't necessarily want to mess with the bandwidth part of it right now. Okay. So we don't need that URL. Isn't that needed either? Okay, so we need to rework export state. And then this is complaining that we're not implementing task ID. That's right. That's something that I implemented recently. So we are pulling this from a model now, but what I'm not clear about is what the initial, what initially creates this task. So what kicks this off? So this constructs something. What starts a new HTTP download? I assume that would be in the download service. Is it really this? I don't think actually anything does. And we have a download URL CLI command, right? Let's see. Verbs. That just fires off directly. What verbs do we have for the CLI for the Nexus Web API? Login verbs, tool verbs, Nexus API verbs, API verify, download links. I guess the links. Yeah, funny enough, I don't think anything actually calls into that download service yet, because the service itself, I think, is listening to the NXM links. RPC listener. Add an NXM task. There we go. So this is where it happens. We get the task from the DI container, and then we init it. And then when we add task without starting, persist on start is what actually calls the export state. Okay, so the way this process currently works is we have a request that comes in for a URL or an NXM link. We then ship that. We then create a new task from the DI container. We hand the URL to the DI container. It sets up some internal state. And then we ask it for its state, and it persists. I think we can swap all that around and fix it. So instead of handing it the URL and getting back nothing, and then we have to ask it for its state and push it out, we are going to hand it the URL and a transaction, and it will hand back to us an entity. Yeah. So this init command, does download task have an init? No, none of these actually have an. This init is not part of an interface. It's part of the. It's just part of the specific concrete type. So we begin a transaction. We hand the transaction to the init command. We have async task. We don't actually need anything from this, do we? We just await the init, and then we return. And we will say that this here has to create its internal state, add it to the transaction, and commit it. Yeah. So we don't even need the transact. Well, we need the transact. We'll pass in the connection. Although it can get the connection from the DI container. So it becomes this, and then add task. It does not need to persist on start. And then start async starts the actual work of the thing. Yeah. Well, this says it's set for testing. I don't know if I won't clean that out yet because we might need it for testing. That's what the comments say. Okay. So we said we were working on the HTTP downloader task first, so let's do a wait on here and that. So now we do HTTP download task, and then our init command using var tx equals con.begin transaction, and we grab we have the download service owner. Oh, that's interesting. That's how it gets the owner. All right, connection. And we do here. We want to save the connection off. By convention, I use the word con for connection. Okay. So our task is going to be a new downloader. What is that? It's a download. Downloader state.model. In that transaction. So how are we getting the size of this before? Oh, here we go. We don't necessarily know. Yeah, so this is where we update the persistent state, is when we actually figure out the sizes and stuff. After we initialize the download. Okay. Yeah. So we're working on a downloads page right now, and we definitely do want to look into the additional attributes on that. So ideally, this code here that does the init download, like right now we're setting the friendly name and the size in bytes. In the next NXM version of this, we should also set the mod ID, the file ID, the game name. We should attach the mod name, the author, really like everything that we get from the Nexus onto that. And then my thought is we can link this download entity to the analyzed archive, which is then linked to the mod. Like, there's no reason after this download's complete to just kill the entity. We mark it as completed and let it sit, you know, and then we kind of have this history. What's kind of cool is we can look at the history over time of the status attribute, because, so, I don't know how many people we have here, but the new database system that we have, and kind of the selling power behind Datomic as a database, and then Mnemonic, which is kind of based off of that but condensed down smaller, is that you can view attributes over time. So every time we set that status, not only are the old values retained, but we also track them over time. So we can actually see, like, when did this download happen? Well, it was when the completed attribute was set on this entity, or like the last update of it. And doing a lookup like that is really fast, because we can go and grab and see the status changed to completed at this point. That references a transaction. The transaction has a timestamp. Boom, we're done. So kind of cool. So yes, we want to, when we create this model initially, what's in this model? Status, download path, friendly name, downloaded bytes, game domain, version. So we don't know version, game domain. We don't know downloaded bytes. Well, that starts at 0. So we we have status and URL, and I guess downloaded bytes is 0. Okay. So the status equals download statuses dot I guess idle. Download path is going to be that. We have a friendly name that we don't know yet, so I guess we can set it to this for now. Downloaded bytes is size 0. And then the rest of it we don't know. So then we commit the transaction. So this needs to return a task, async task. So now we await tx.commit. And then, so this entity will have been created at this point and assigned, and when we create it here, it hasn't been committed yet, so it's a temporary ID. Once this commit happens, that resolves to a real ID, and so we need to store that. So then we do state, not state, it's our model. Did we not do that on this? Yep, not yet. Private download state model. I don't like this, that we have state and downloader state. I'm gonna have to look into if we want to adapt that. This is the time to do some of this work though, because we only have 2 implementations so far. Okay, so the downloader state, we need to resolve that to a real ID, and we also want to change the ID of that entity. So the way we do that is by remap task. So we have this task, we have the ID, we remap it, so now it has a real ID, and this is complaining because it's read-only, make it non-read-only, and then we return. We didn't have our URL, so we do need to do that. Now this is a little weird because I don't want to create a whole nother model just for this. So what we're going to do is tx.add. So we're going to add this transaction task.id, and then the attribute http downloader state. There we go. And this is complaining because what's the problem here? Oh, our URL is not a URL here. So the question is, I can't think of a use case for the history of the status. Yep. Yeah, I agree. The nice thing is about a lot of this stuff is that the some of these changes to the attributes can be applied afterwards. So if we go to our downloader state here and we don't want history on status, no history, true. Now, one of the things here though is that without, so if we don't track history on this, yeah, no, that's fine. You're right. Yeah, so we don't have to track the history on this, but what we will always have is the most recent value of this, and then that links to the transaction. And to some extent, the question is, does the data just kind of sit around forever? Yeah, it kind of does. Everything has a transaction log. The log, exists forever. So doing no history does reduce a little bit the amount of data we have to store. But that's about it. I mean, like, the status will always be there in the transaction log until we implement a redaction system or a like excision system that's like kill the history for the database, right? Okay, so cool. So we have it in it. What I like to do at this point sometimes is go and see what's not. Okay, so we don't have yet is this task ID, which I implemented. So that's done. This is just a way to grab the entity ID that this task has created behind the scenes. And then we have one more compile error in here. Okay, cool. So this export state, this is what I want to pretty drastically redo here, because we don't have much of a use for it anymore. Indeed, we don't even have persist on start used anymore. So here we use it. So we really just want restore from suspended. Doesn't even need a model, because who uses this? Because it comes from here, get task from state. Boom. Like, what I've just done is like we rip that one part out, and then because of that, these function, this doesn't need it, this doesn't need it, this need it, all the way up to here where we can just pass in the ID and don't need to resolve it all at all, which is really nice. So this can just be entity ID. We do have to discriminate the type. So maybe we do want that. Because we still have that funky dispatch system here. So okay. But download location, we do kind of want. Okay, so we'll kill the export state because we don't need that. And now this is complaining that we don't have export state anymore. So we'll yank that. Ah, no problem with the answers. And I gotta figure out how to reduce the latency on this because it's sad how long it takes me to see the questions after you ask. All right, so if we look at the download task, we have resume. So what I want to kill next are these attributes. Well, this one specifically. Default downloaded size. Okay, no, we'll keep that because as we accumulate more, that'll go in there. Okay. So here the status switches to that. So what I'm trying to solve here is when we go to resume, or I guess even when we cancel, update in data store. Okay, so that's fine. I don't know. I think we might be good. I was thinking there might be a reason to call into the task and tell it to serialize whatever stuff it has, but it's kind of doing that on its own. Oh yeah, but on our HTTP downloader task, we do have this init download. So we're setting friendly name and size bytes in the wrong spot. Okay. So what we need to do is rewrite this. So friendly name is friendly name. Size bytes is now size bytes. We're going to pull directly from the download bytes. We have downloaded bytes, but we also want the size, the total size. I'm going to rename this in just a second here. I don't like units as part, like the unit should be part of the type is not, and not as part of the name. So now we have downloaded and size. Before I commit this code or submit this code, what I should do is make this optional because we may not have the size. Currently, the way this is coded, it'll throw an exception when we call the get, and I don't want that. So I'd like rather it be optional. So this is now complaining because it needs to implement set according to download task. So let's see who uses the set. Find usages. The NXM does, okay. Task.status, status. But then we go right away and update it in the database. What's interesting is I would rather not have this update in data store be part of the parent of the owner, because it's kind of reaching into the children now and taking their data and committing it. Instead, we should have an abstract base class for these tasks that does that. So we just like save state. The owner then becomes save state, give me your ID. I'm gonna do something with that, and later I'm gonna come back and say restore yourself and resume. Yeah. So this is in networking downloaders tasks. So the download task itself is going to have a so much of this can be pulled into the base class. So we're going to get a DI service provider, and then from that, what the heck, we're going to do, and this is going to be a connection, connection, and then from that, we can do a public void set status. So, and then our download service And then this is downloaders. Why is that saying state? That's not what I want. I'm not sure what's up with that. This is protected. There we go. So now what we have is we can move this downloaded to a public downloaded size, downloaded size bytes. I'm just going to call this downloaded. And then there we go. Now this is complaining because, oh, this shouldn't be a byte. And this is complaining because, oh, I got a name collision here, don't I? Yeah. So this should just be state. Oh, that is a byte. Okay. Cool. So when we set the status, then we do this, and boom, that's done. And then this is just state. Cool, so that gets the downloaded, so this is now a base class that we can implement up here. Oh, and then this should include I download task, a download task. So what can we, yeah, this is really starting to get interesting because we can keep reducing the size of this interface way down. So we can get the friendly name and everything from this state instead of actually requiring that in the downloader service. Because what do we actually use? So if we go to the iDownload task, what do we use, like, let's see, friendly name for? In the UI, we use it here. That's about it. Yeah, I think we're gonna kind of go down that route. So a iDownload task will need to expose not friendly name and status, and nobody even uses owner. Do we want it to use owner? Maybe. We don't need task ID anymore because or downloaded size in bytes. Well, instead, what it's going to be is just downloader state.model state. Now the downloaded size will change fairly rapidly on this. Which does mean that we might want something a little more advanced on this size, not on the size, on the downloaded value here. Because we want this to update, but we want it kind of lazily synced to the database. We don't want it written out on every change. Because it will update really fast. It is getting late here, so I think I'm gonna get some supper, lunch. It's lunchtime. Get some food, think about this. But I think what we're gonna do is we don't want to spam this value. So we almost want to combine this with another class. That's like, here's what's in the database, here's what's in memory, and we track those together. And then every so often we write what's in memory to that entity and save it. Yeah. Because what I'm trying to get around is this bit of interconnectedness between these. So the NXM download task. Like this thing where we're calling in to get the state and back out. That's a bit icky. And this is a bit weird too, the way some of this is broken out. Some of that's needed for testing, and we'll look at that. But like here, we're just copying the values. There's no reason to copy these, and they hide the fact that the data is on the entity in the backend. So the more we can kind of deal with that would be great. But we do need throughput. This is attached to a task and various other things. So I think really we keep that as part of the task then, right? That the task is the combining class. So calling these should save and update this state. And throughput, so internally, a download task should have private size downloaded. So the HTTP download task, what currently sets the the default? Oh, we just go off the report here. Well, that's interesting because the HTTP downloader state is just an activity. And this also has that. Okay, so this abstract base class will need to have an activity source. So the activity source is a way of reporting to the app at large of a long running task, like you're downloading, you're extracting files, that sort of thing. So activity source. So our find usages. Does anything set that activity? I don't see that anything's creating that activity right now. Oh, I see. The simple or the advanced downloaders set it. So what else uses this state? Okay. The only thing they ever get from this is the activity. They set the activity. So we could change this as well to take, instead of downloader state, which it never uses, it can just create an activity state. Like it can just hand a setter to whoever calls this of like, here's my activity state. Do something with that. This is expanding to be more and more work, but it's good to clean this up. So in this, if we assume that we're going to want exactly the format is in the, that's in the, as here, so well, that's all there is to it. It's just an activity. Okay. Who uses this? Okay, so changing this interface isn't going to be huge. All right. So our A download task then has an activity source. And someone will eventually set that. So we'll set that to null for now. Instead of this being download, then we want to set this to I mean, it doesn't hurt us to have an HTTP download task here, because I guess that's the common interface. HTTP downloads downloader state. Is that it? Yeah. So it's the downloader state. And what we'll say here is if downloaders download state does not equal null, then we're going to set the to so we're going to do the down activity status, make report, current value or 0, downloaded, boom. Cool. So this is saying download state cannot be null. Now it can. Cool. So now we have the set status that optionally sets the size when appropriate, syncs that. This is complaining that we don't have like calculate throughput, cancel, resume, so on and so forth. Cancel. We want to implement missing members abstract. So this is going to be state. Owner. Download service. And then we're going to return that here. And this can actually be No longer abstract, and then we can just do auto property. Cool. So from here, what do we have here in the download task? That's the problem. Okay, so setting up the task, HV down. We do need to. Oh, this is tests. So this needs to call its base of all right, I'm gonna rework all of this. So I'm gonna get some lunch. Thanks for hanging out, everyone. We'll probably do this again tomorrow or something. And I really like the Midnight. The music is my favorite group to listen to. I realize talking over this music is a little hard, so we'll get some other synthwave going tomorrow, or whenever I do this next, probably tomorrow, and try to get a little more done on this. So thanks for hanging out. Great talking with you all, and we'll see you again soon.